ETAP 2026 come up with quite a lot of features. Let's get started. Yes. So the software ETAP 2026 or ETAP 26 is up. And like means to say, when it is opening, it will open like this. So you can open an existing projects, or you can open a recent projects from here, or you can create a new projects from here. So like when you're opening ETAP, like means to say ETAP screen appears with this ETAP launchpad. From there, you can open like means to say recent projects. You can open maybe old projects by means of opening here, like maybe only 5-10 will appear. Like if you want to open like the very old, like you can use open projects. If you want to start a new projects, you can create a new projects. And if you want to probably look at a list of recent projects that you can look at, if you want to look at like means to say explore this software with the tutorials and examples, you can explore that with the tutorials and examples. Of course, we are going to start with the brand new projects. So which means we are going to create a new projects. But like means to say, ETAP gives an option to open recent projects directly from here, or open old projects here, create a new projects here. It helps you to look at like means what are the recent projects which has been opened. If you want to look at the tutorials and examples, that software allows you to do that also at the beginning. You can probably create a new projects, or you can use some of the recent projects also. Our objective is to start with the new projects. Let's get started with the new projects. Let's say create a new projects. Let's probably like start our first projects and probably like let's look at like what we need to look at. So when you start the projects, like I mean to say, unlike Windows, where you open Word or Excel or slides, PPT, you do whatever you want and finally you save. But here, when you are starting a new projects, it will automatically save before like where you are starting. So you need to decide where is the location which you are trying to save. So when you are saving it, like you have a C, you have a D, or you have a network, like it means to say, like I'm just probably like means to say saying like new folder, saying ETAP 762026. What I have done, I have selected in D drive ETAP 707062026. That's pretty much like what I have given. ETAP today's date, which I have given, and probably like means to say, let's say project one, that's what I'm probably creating. Assuming like if you're selecting multiple projects. So where my file is going to store ETAP 07062026 project one. Let's parallelly open the folder, whether it gets generated or not. As soon as like if I give OK, this will save. So I'm just trying to ensure that like means to say, I'm just giving metric and 50 hertz is a system at which which I'm probably trying to like means to say use. If you are probably from USA, Canada, Philippines, or some other country which uses 60 hertz systems, you have to select 60 hertz systems. And if you want to like save this file with the password protected, you can check it. And open database connectivity, whether you want to save this database in the local or probably like SQL server, you can give. So time being, I'm giving it in my local. So I have selected the location of the project, named the project as project one. I selected the units since I'm trying to do a project with a 50 hertz in the metric. Password, like I don't want a password, like I want the file to be open, so I left it without a password. And open database connectivity, I'm keeping it in a local server, and I have just given OK. One more OK, and then my projects has arrived. And when my project has arrived, in the background, like means to say that file has been created. ETAP 07062026 with a 39 MB file which has been already created with the project 1. So if you look at like projects 1, like I mean to say you have .OTA, that OTA stands for Operation Technology Inc. That's like I mean to say that's the name of the company which developed the software ETAP, and probably now the company has renamed themselves to ETAP. And MDF, that's a database. So like what's the single line diagram which you're going to draw here? That's going to be saved at this place.ota. What are the parameters which you're going to give? That's the parameters, like if you're choosing bus or a transformer or a transmission line, what are the parameters which you're going to give? That database is going to save in this place. And probably like if you look at already that came with 37 MB. That file came with 37 MB, and that's 37 MB. That's because like it has by default some old database of that relays, cables, etc., etc. So even before I start with anything, this already has like about 37 MB file which has been stored there. So I have just opened a new window to start a project so far. Let me get started. So like we have like multiple groups. Start with edit model, load flow group, short circuit group, relay coordination group, R plus group, safety group, harmonics power quality group, dynamics group, optimal network group, optimal switching group, cables group, renewables group, control system group, traction railways group. So like there are multiple groups are there. Like these groups are not there earlier. Probably like software, they have updated everything, right? So like this version ETAP 2026, like they are trying to add artificial intelligence as well. So that like means to say they can save quite a lot of time too, right? So if you are looking at like you have a file where you can open, close, save, copy projects, share, change this data, print, log off, exit, multiple things, and probably like size like means when it is opened, like who is working on like all this informations are available. You can do user manager, check for the issues, recover projects, all these things like which you can do, including the preference, right? So like looking at like means to say this file option, like important option from the perspective of project, that is preference. So this preference will give you multiple things. So this you have to definitely watch. Like there are multiple parameters which can be controlled. Say example, like I'm opening ETAP projects as an one example. Like I'm putting like means a voltage control source as a swing source. Like it's true or a false. Like I have two options. I'm just keeping it as in a false, and I'm trying to like I'm just opened only one option. And then probably like means to say trying to model a generator. There is a generator which generates, and via step up transformer it steps up, and power is transmitted over a long distance to the remote bus, and like we are done with the network. Or probably like means to say if you want to probably recall your college theory single machine infinite bus system, you can put like means to say one more like I mean to say line also, double circuit line also. But I have not given any parameters or any values. I have not given voltage, I have not given powers. Like if I run, like nothing will work, but at least I have created a skeleton single line diagram. So the skeleton single line diagram, this helps two things. Like there is something called check circuit continuity. If I click this check circuit continuity, if I click check circuit continuity, it is all goes to dull color, because we know in electrical power systems without one swing bus, you cannot run anything. At least you need one swing bus. So if you make it swing bus, it is energized. But if you put like your generator in a voltage control mode, This goes to dull color. So what's the option which probably helps to differentiate what is energized part and unenergized part? The option is called check circuit continuity. Over and above, like this check circuit continuity, this file preference is helping you to evaluate voltage control source. Like if all the sources are voltage control source, shall I convert any one of the voltage control source as a swing source? If you are making true or false is the answer. If you are making it true, like means to say this network it enables, that's because it automatically find out like means to say what's the highest rated voltage control source that it converts into the swing source. Such options are available in file preference. This is an important aspect like which you need to probably look into. Each and everything. Say example, if you're doing a load flow, you need to really look into this. So like means to say what's the maximum iterations, what's the like means to say persistence, what's the SVC, like static or compensators adjustment step. So what's the maximum time for the calculation timeouts? So like when you have a decoupled load flow, what's the precision? So all this informations are probably like means to say has to be given here. So the first and most important aspect, like which you need to probably go through when you want to become an advanced user, is this preference. But like we have probably created a model. What I have done, like I have blindly created a model. I have blindly created a model. Like I have put up a generator, I have put up a generator step up transformer, I have put up a single circuit transmission line, but I have not really like means given any parameters. Let's start giving a parameters to the system. Let's assume like I am having an 800 megawatt generator. 800 megawatt generator generating power at 28 kV and at a power factor of 85 would be like a decent power factor. That capacity, right? Typically, the generators will have zero point 0.8 power factor lag and 0.95 power factor lead. But like means to say, when the capacity is higher, you may not really need like means to say 0.8 power factor, 0.85 or zero point 0.9 power factor may be good enough. So here, like I have selected 0.85, I have not left it the default. You need to understand what's the capacity of the generator, and for that capacity, what's the power factor, like that you have to enter properly. And then probably like means to say how much real power it generates, what's the Q max, what's the Q min, all these parameters which you need to select. So how to select and how to enter these parameters? Like means to say that like means to say you need to understand there is something called generator capability curve. So like when you're learning power system simulation software, there are two important aspects which you need to look into. One is the software. Second one is these concepts or the basics. Without understanding, without understanding what is the capability curve, what is Qmax, what is Qmin, how to read the generator data sheet, etc. Like you will not really be able to model this generators. So you need a little bit basics, theories and stuffs. Let me, I guess like the keep adding is that is going on, and let's wait for add to close so that our own channel, but like we couldn't watch without ads. Okay, that's the second ad. Now wherever the video which we are doing, right? So I'm just sharing the link. I'm not really going to explain more on these topics, but like this gives you an idea, like means to say what you need to understand, what you need to understand as a capability curve of the generator much before you are jumping inside modeling ETAP. So like means to say you can go and probably like means to say watch this video and probably like means to say ensure that like means to say you're going and probably watching all the videos which are available in our YouTube channel. Each and every video adds definitely a lot of sense, and probably like we are adapting to new generations also. Now we are coming up with very short 1 minute 2 minutes like I mean to say thoughts as well. So ensure that like means to say you like I mean to say go through like I mean to say either videos, shorts, or probably lives as well. Like we have done like quite a lot of lives in the 2020. After that, like means to say we have stopped it. But like YouTube lives also adds beautiful informations like maybe power factor correction part one, power factor correction part two, etc. So that's on the subject which you need to learn. But I'm assuming that like means we have that fundamentals and probably like means say proceeding it, putting like means say 800 megawatt generator, which is capable of generating how much real and reactive power. Let's look at 85 power factor lag, which corresponds to 490. So 800 megawatts. I guess like what I have done is I have cancelled it. I have not given OK. Right. 800 megawatt that corresponds to 495 MVR and 95 leading power factor that corresponds to minus 262 MVR is like what I have given. So now like what I have done, like I have connected a generator. I have connected a generator which is 800 megawatt whose voltage is 28 kV. Its power factor lag is 0.85, power factor lead is 0.95. It's generating 800 megawatt and the corresponding full load current is about like 19,407. And it is, maybe you can assume it's a two-pole machine, runs at 3000 RPM. So this capability curve, how to model, that's what that video explains. You can go and watch. So I have just modeled the generator, that's it. So you can probably like still run load flow and you can probably check it like means say you're like I came to like load flow group, power flow group. I have probably picked up load flow and I'm just running the load flow. It gives like quite a lot of errors. Why it is giving a lot of errors? It's obvious reason because like means to say I have not really like means to say model all the parameters. Say I have never given what's the voltage of this bus 2. So 800 megawatt generated at 28 kV. This needs to be stepped up. So like I need to give like the voltage. So I have given a voltage. Now let's run load flow again. Check like is there any errors? Transmission line has incomplete parameters, line impedance, transformer MVA is 0, transformer XPR. Like so, the software is very helpful and handy from that perspective. The software is very helpful and handy from that perspective. What I mean by that, like means software helps you to tell like what are the errors, and if you click that, it will automatically take to that page. Say example, transformer MVA rating is 0. So what I have given the transformer MVA rating, what I have given is 0. So like means so see if I am giving like transformer rating is 945 MVA. If I am running load flow again, it says like positive sequence impedance is 0. So if I am giving this, then probably if I am running, that error has gone. Like now only the error is in that transmission. So the software is useful. It tells like what are the mistakes which you are creating. So it makes your life easy. So far, it's clear. Just put CC in chat. So far, it is clear. Just put CC in chat. So far, beautiful. Thank you so much. Cool. So technically, so far, intentionally, I have made a mistake. Technically, intentionally, I have made a mistake. What's that mistake is? Let me answer this. Let me answer that. That mistake is I have just blindly selected the transformer impedance. I have blindly selected the transformer impedance using typical second XPR. This is where like you need a basic subject knowledge. you should not use typical Z and X by R ratio from ETAP. Like means using typical impedance and X by R values in ETAP is strongly discouraged for critical power system studies. Relying on default estimates often leads to dangerous and inaccurate results. That's probably taking to our blogs. So one thing which I have talked about our YouTube channel, the second one which I definitely need to talk about is our blogs. Visit india.com, reach out to the blogs, read all the blogs. So like the typical values in ETAP is coming from IEC 60076 Part 5 1994. But this IEC 60076 Part 5 has been updated way back in 2006, which means like 20 years back, the software has updated the impedance. Like even today, ETAP 26, if you look at the help file, which we can understand from where it is taking a typical impedance from, right? It is taking impedance from IEC 60076 Part 5 1994. It's not taking from IEC 60076, like the latest standard, which is 2006. And probably like means to say, if you have to look at like means to say what's the latest standard, let's look at like what's the latest standard, IEC 60076 Part 5. Let's put like what's the latest standard? Latest standard is 2006. So hope it is clear. Like so you should not blindly rely on the software alone. What you need is you need to know like two important aspects. One is your basic fundamentals. Second one is the software. Both has to go hand in hand. Only software, no use. Only knowledge without a software, you will still rely manually, and that takes unnecessarily lot of time. So you need both basic fundamentals as well as the software. So like generated 800 megawatt at 28 kV, stepped up to 400 kV, and like still line parameters which we have not given, like 300 kilometers, and like means to say let's assume this impedance as 0.08, maybe 0.08, 0.4, 3.6. That's pretty much of it. So I have given now all the parameters of the generator, transformers, transmission line, sufficient to run load flow. Let me repeat, sufficient to run load flow. Like if I want to display any other parameters of this equipments, so I have display options here. I have display options here, right? Like though I am in power flow group, like power flow, like means there is a display options here. I can display like what I want to probably display. So whether I want to display, like say example, if I want to display the transformer voltage, I can display. If I want to display the transformer impedance, I can display. Like if I want to display the tap cushion, I can display that. So 945 MVA, 28 bar 400 kV, 12.5% impedance. That's it. And like I want to see the transmission line parameters. Yes, I can probably like display the transmission line parameters. So line, I need to probably like specify the line impedance, line size, type, length. Something this. I probably take means to say impedance parameters can be displayed. If I am running load flow will run. Load flow will run. It gives quite a lot of insights. It gives quite a lot of insights. Honestly, it gives quite a lot of insights. Let's look at like what are the insights. In order to understand the insights, first like we have to display with units, and probably like let me display it in megawatt MVR so that it is easy. I'm displaying the angle as well. I am displaying the losses as well as voltage drop. So like we have given lot of parameters. So in each branch, like we have displayed lot of parameters. Here, when the generator is maintaining its voltage at 100%, HV side the voltage becomes 400 and above. It's not 100%, it's 102.4 percentage. The voltage has increased, and probably like the remote terminal, the voltage has further increased. The remote terminal, the voltage has further increased 109.5 percentage. So here, like means to say, one thing which is very clear, the line, the real power loss is 1.34 megawatt, whereas the reactive power loss is minus 187 MVR. That means line actually generates about 187 MVR. Line generates about 187 MVR. And the line which is no loaded, though there is a generator, like I have not really connected any loads here. So whatever the reactive power generated by this transmission line, whatever the real power loss which happens in the line, that has to be met by this generator. So the line is generating about 187 MVR, and there is about 4.43 MVR loss in this transformer. So line generates 187 minus reactive power loss. The generator is consuming 183 MVR, like it is clearly there, arrow mark with a down, but with a negative symbol. That means the generator is consuming 183 MVR. Line loss about 1.34 megawatt and 0.099 megawatt in the transformer, and probably like means 1.44 megawatt is like what's the real power generated by this generator. So this generator meets how much power which is like I mean to say demanded by the network, because here there is no load. And here if we talk about this is Ferranti effect. High voltage or extra high voltage, lightly loaded or no loaded, long or very long transmission line, receiving end voltage is higher than sending end voltage due to the shunt capacitance of the transmission line. That's Ferranti effect. So if you have studied something in the college, what we are seeing here is a Ferranti effect. What is Ferranti effect? In a high voltage, extra high voltage, long, very long transmission lines, during no load or light load conditions, receiving end voltage is higher than sending end voltage because of a shunt capacitance present in the systems. That's pretty much like what you have simulated. So, like means to say, in order to do this such a simulations and probably like making it concepts clear and probably like validating it, obvious you need some basic concepts. And probably like means to say now, like means to say the line has generated about 187 MVR, and probably like means to say, whereas the loss is 1.34 megawatt, approximately the generator is generating 1.44 megawatt and consuming 183 MVR. Let's add only one like grid on the opposite side, like to make the system single machine infinite bus, just to make this grid on the other side, opposite side. That's it. Like I have not really done anything. I have not even given any parameters. Like means to say the system was as it is. I have added only one generator on the other side, and probably like I'm running the load flow. Let's see whether the previous results, the present results are one and the same. Wow. Like I mean to say the results are completely different. Previously, the generator was consuming about like means to say 180 MVR and generating only 1.44 megawatt. I have not done anything except connecting the grid. But now, like if you look at like the generator generates 800 megawatt, generates 85.6 MVR. So there is 1.9 megawatt loss in the transformer, 85.6 MVR loss in the transformer. So other side it is going 798.1 megawatt at almost 0 MVR. And when we look at the HV side, like means to say, there is about 98 megawatt loss in the transmission line, and like 319 MVR loss in the transmission line, which means like the grid, like even if I am generating 800 megawatt, like means only 700 megawatt is reaching. Even if I am generating 85 MVR from the grid, I am drawing 319 MVR. So like this is what probably like you have to infer the knowledge from it. Let's open up an example. Let's open up an example and then let's see, like I mean to say, is there anything which we can probably like I mean to say do or probably like showcase the capability of ETAP. So if you're in ETAP, so this is one of the project which has been done obviously using ETAP. So this probably has multiple things. 33 kV utility bus with a short circuit MVA 500 MVA. There is a step down transformer, like stepping down from 33 kV to 11 kV via 15 MVA transformer. There is a three winding transformer. There is a synchronous motor. There is an induction motor. There is a capacitor bank. There is a distribution transformers. Like there is wind turbine generators. There are like means to say solar panels, variable frequency drives. This is intentionally, this project has been created with all possible equipments to be connected. So that like means to say this gives some insights. So this is where like means to say I'm just talking about one among multiple features of the software. So like if you talk about the like protection coordination, the software has like means options like load flow, where you can perform load flow, you can perform short circuit. Short circuit you can perform in IEC, ANSI, GHOST, multiple standards. Like a relay coordination. If you talk about the relay coordination, ETAP 2026, this is the new feature. Like means to say, originally the equipments are capable of like I mean to say like means interrupting the fault current. But nowadays, like means you have like current limiting circuit breakers also in the low voltage systems. They have the capability to limit the short circuit currents as well. So previously, like such a lead through energy concepts or like means say current concepts, current limiting concepts or features are not there in ETAP. And probably like means say growing technology trend, ETAP has identified that and probably like means say you can implement that in the latest simulation softwares. So this is one among the simulation, like one among the additional benefits where the industry, where the uh, software is developing their features and probably accommodating it.